let's see what factors affect the limiting friction. Now, to understand this, let's consider this example on your screens. Suppose that you have a box of mass m lying on the table. The box is applying a downward force, Fg, which is also its weight on the table. In reaction, the table exerts a force R on the box. This is actually the scenario where your box is not moving and it's at rest. The magnitude of both of the forces, Fg and R, is the same because your object is at rest. However, both are acting opposite to one another. Now, in this scenario, if you divide the force of limiting friction, Fs, with the reaction force R, a constant value is obtained. This constant value is called as the coefficient of friction and is represented by mu. Mu is equal to Fs over R. And you know that when the object is at rest, R is equal to mg. So, the coefficient of friction becomes Fs over mg. If we rearrange the equation, the force of limiting friction becomes equal to mu times m times g. So, the force of limiting friction depends on two things: the coefficient of friction and the weight of the object. Guys, here on this side, you can see a chart of the coefficient of friction between some of the common materials. You can pause the video here and read the information about the enlisted materials. Interestingly, there are some mathematical relations involved in friction as well. These we'll discuss in the lessons to come, and we'll also look at the types of friction. Stay with us.